Wow, that was some spectacular time lapse, wasn't it? Those towering cumulus that you saw off to the left, that's probably some of the best footage I've got of anything like that in the past several months. We're down to mostly anvils, as you can see here. This was taken about 45 minutes ago. A few gravity waves up at the very top, kind of moving through the flow. But we've got some thunderstorms in the area, and I can hear a bit of thunder outside. Let's head to the charts and see what's going on. Let me zoom this in real quick. You saw I had some notes up about astronomy. I wanted to cover the astronomy bits a little bit. Here, I'll let you look at the temperature anomalies for this evening. We have a new moon tonight, 9:46 UTC. We have a meteor shower in about a week. That's 29th and 30th of July. That's the Delta Aquarids. Then we have a partial lunar eclipse on August 7th, but that's only going to be visible in the Eastern Hemisphere. Our Australian viewers will get a look at that. And other than that, we've got the days starting to shorten. We're losing about 1 minute as far as sunset, and a little less than a minute as far as sunrise. So about a month from now, we'll be looking at sunset times being about half an hour earlier. Okay, here's what's happening across Texas and Oklahoma. And of course, we do have a focus on this part of the country, since this is where I'm at, and we're a little bit Texas-centric here. But you can see very easy to spot boundary from west to east, from Memphis to Little Rock to north of Dallas. And north of that, we've got north winds. And when we have an uncapped air mass like what we have, this is nothing like April and May where we're capped. We're usually very uncapped this time of year, so it doesn't take much of anything to get storms to form. We just need a boundary and a little bit of cool air in the mid-levels. Now you can kind of see that the flow is disrupted in central Texas. Like right here, you can kind of see an area where wind flow is radiating away like that. So obviously there's some sort of boundary in here. Here we can't really tell what's going on. I will tell you another product you can use to kind of pick this out. Go to Surface on this SPC Mesoanalysis site. You're going to go to Surface and Deformation and Axis of Dilatation. So now you can see boundaries here. So these long blue lines, they tend to parallel the convergence along the boundaries. So right here, pretty good indication of a boundary, also in the Big Bend and in East Texas. So that's another tool you can use. More boundaries up to the north. So head to this product and use it for your mesoanalysis. This should not be used in place of your hand analysis, but this can help you find boundaries that you might otherwise miss. I think we have some storms up in the maybe eastern Midwest, or the, yeah, let me pull up that sector here. There we go. We got storms all the way from Indiana and Illinois all the way down to the Carolinas. If we put the deformation on, boundary's a little bit less clear-cut, but they're kind of elongated in that area. This is going to be a little bit more valuable before storms form, but once again, you can kind of use this to kind of figure out where boundaries are, such as up here, northwestern Ohio. There could be an old boundary left behind up in that area. Okay, as far as temperature anomalies, we do have a cold air mass coming into the Great Lakes area. Hard to believe you go a little bit further north and it's warm. Here's a look at the plots. We'll go up north, and we can see up in Hudson Bay, 75 at Churchill, and 77 at either Winnisk or Fort Severn, I forgot which. But some very warm weather, and 72 up in Nunavut territory. So up to the north, probably a cold front coming south, maybe something like that. And it's kind of weird, you know, you go south into the Great Lakes and you go from 70s down into 60s and even a few 50s. So that kind of reinforces the idea that the cold air doesn't necessarily come from the polar regions. It can be generated at lower latitudes. All you need is good radiation and clear skies, and you can get rid of that heat pretty easily. Also, dynamic cooling, like if you have dry air and you have precip falling through that, you will tend to chill the air to the wet bulb temperature. That's called wet bulbing. So that's another way to generate a cold air mass. Got a cold front moving through Illinois and Michigan, and here's the leading edge. Looks like it's just coming through Kankakee and still north of St. Louis, maybe coming through the Columbia area and all the way down to Kansas. So we've dropped in Kansas from 103, 104 to 96 and 92. So cold air is coming south. And then, of course, further south, we've got the usual boundaries kind of piled up in this region. And then we'll check on the monsoon. We can see the large-scale synoptic convergence, not the small scale, but the large scale. You can kind of see all this flow kind of heading into the interior regions where we have the very intense heating out here. Temperatures are not too hot in Arizona, but if you go into the California interior, we've got 103 in the Stockton area down to Fresno, 104 at Bakersfield, and 110 out in the Mojave Desert area. And even up in Northern California, 104. Let me just take a quick look up in Oregon. And yeah, they've got it too. Go a little bit east of the Cascades into the interior. Got 96 and 100 and 97. Okay, so that's some very warm air. But I can see some westerly flow up to the north, so that may be breaking that hot weather period. Let me put on the potential temperature. See if anything comes up here. Now this is a kind of a smooth pattern, and that's going to cause problems because I think I've probably gone over this about maybe a week ago. But if you over smooth these potential temperature lines, you're going to be influenced heavily by the ocean. So what I like to do is I come in here like in digital atmosphere, and I'll knock this down to coarse, and then I'll redo the plot. So let's try that again. Okay, analysis temperature and potential temperature. So it's a little bit more granular, and now you can kind of see a little bit of detail right there. Keep the boundary to the south side of that gradient, and that's going to be your front right there. So sometimes it really helps to get rid of the smoothing, even though you get a very noisy field like you see here. This can help you find your gradients, and you know, you can kind of pick your way through here. You can find bad plots, or maybe plots that are affected by precip. But in other areas out where there's not much weather going on, looks like maybe boundary right there. So this is another tool you can use. Just knock that smoothing down, and if there's a bad station, like maybe here in Oklahoma, you can get rid of that. Digital atmosphere does allow that, so I'm just going to take a quick look at the values here. The values that go into this potential temperature is strictly dew point and altitude, so let me just check this real quick. Except 120, okay, 21. Yeah, okay, there's a bad reading right there. 6 degrees Celsius, that's 41 Fahrenheit. So I'm going to delete that. Then I'll accept that. Those all look good. There was a 99.99 that was missing data. That's fine. Okay, so when we plot this, you're going to see a much different picture here. Potential temperature is basically the same thing as theta, so just keep that in mind. You'll see some websites use it interchangeably, so now we've gotten rid of that bad plot, and now we can a little bit better analyze the data and maybe pick out a little bit of a mesoscale feature there, probably a meso high and the attendant outflow boundary, and maybe a couple of other boundaries in here, kind of similar to what the SPC site had. So that's how we go about analyzing outflow boundaries, aside from just the standard hand analysis. Basically any kind of boundary, even frontal boundaries, you can use that technique there. Anyway, a few wind reports along that Oklahoma, Little Rock, Memphis line there, and quite a few of them in the Carolinas. Take a quick look at the upper air patterns, and earlier in the week you can see we had a very strong Hudson Bay vortex, and there it is right there. This is on, can't find a date on this. Well, this was 20 synoptic periods ago, so probably about 4 days ago. Oh, okay, it's over on the left. Okay, this was Wednesday on the 19th. Okay, so we run this forward, and you can see we've kind of broken down the Hudson Bay vortex, and that big low that was up there is actually shifted out into the Labrador Sea area. So this area here in the Hudson Bay area, that's kind of shifted back to kind of a nondescript flow, so that's going to cut down a little bit on the cold air intrusions into the northeast U.S. And there's a 250 millibar chart there, and you can see the absence of the Hudson Bay low, just this vortex over Labrador. And we've got the jet stream well up to the north, still a little bit of a northwesterly flow into the Great Lakes. Ridge up there over the Canadian prairies, and let's check on our ridge out over the plains. Okay, I'm looking for a closed high. I don't really see one. I just see kind of, if I do the streamlines, I get something like that. So it looks like that closed high that we had earlier is kind of broken down, and we've just got some upper ridging extending eastward across the Central Plains. Maybe a little bit of a closed high in this area, but we are kind of breaking that down there. The main high over Arizona, so that's a closed high right there. So we would expect to find some warm weather there in Arizona. I just realized I haven't checked on my microphone. Let me make sure the audio's okay. I see Alexi yelling Mike up there. I hope that's to Mike Estwick and not to me about my microphone. Okay, got Andrew here. Dew point starting to drop there in Peoria, Illinois. David Moore says a few showers in the Metroplex this afternoon, 97. We've got 83. We just got some outflow. Let's take a look outside. We had a little bit of thunder earlier. Just 20 minutes ago, it was 91 degrees. Let me shift that over to the... There we go. So that's the view outside right now. And I've got 83 degrees. We've had... This is looking south. So we've had the outflow moving from left to right where we're at, and really not too much going on. Okay, Burl H. is joining us, and Kevin McKinney, Carl Berghoff, Ryan Toomies, Alexi. Ryan says, nice cool evening in South Florida. A calm Sunday. Dwayne Ward says, non-severe storms continue across the Delmarva. Temperatures cooling with storms and approaching cold front. Very warm in Denver, where Mike is. Ryan mentioning a strong Sahara dust layer passing into the Gulf of Mexico. Maybe this is a good time to pull that up. Before I head out there, I'm going to just show you this real quick. This is in the Chicago area. There's Chicago, there's Gary, and this is earlier. You can see classic outflow boundary this morning. This is probably about 11 or 12, and a couple storms going up along that. And we advance this a little bit forward. You can see it kind of moving to the south there, so pretty interesting. Okay, let's check out the Gulf there. Wow, either that's serious sun glint or that's dust. Let's bring up the overlay. Aerosol optical depth. And let's see here. For some reason we're not getting any data in here. Let me try bringing up one of the other satellites. I'll try bringing up the Aqua data. And yeah, looks like a little bit of dust just north of the Yucatan. A whole bunch of it north of Suriname, Guyana, north of the South American coast, and out in the western or the eastern Atlantic, pretty quiet here, and then another plume of dust off the West African coast. So these tend to move eastward with the trade winds, and they do make it into the southern U.S., and when the dust moves inland, I'm not too sure what it does with precip. Ryan might have a better idea, because I haven't really followed dust effects too much, but it does cut down the visibility a whole lot when it moves like into Texas or Louisiana, and we see visibilities go down to about 2 or 3 miles. Okay, to make sure that's not sun glint, we can just pull up another satellite image. We'll go to Aqua, and of course conveniently I think we have a gap here. Yeah, there's a gap. So I don't see a whole lot of dust in here. That could have just been some sun glint. Yeah, see that shifted. I don't think that is, let me zoom out a little bit. Yeah, okay, that's sun glint. See. Okay, so those aerosol products, those will help you differentiate what you're seeing there, just as we've seen right there. And we've got a couple tropical storms out in the eastern North Pacific. I'm not really covering those too much because they don't have too much of an impact on the weather, at least right now. But if they start moving up to Baja California, we will cover them. There's the thickness chart for valid for right now. And this is very synoptic scale. So what we see here, cold air advection in the Great Lakes. This is all cold air advection. I'll just kind of shade that like that. Warm air advection in the northern plains. This is all warm air advection area. And then we have cold air advection up to the north. And probably not so much off the west coast here. Mostly up in Washington and Alberta. So we can kind of use that to place the fronts. Probably got a warm front here, and I think we did see that on the data when I did the potential temperature. Western Dakota's right there. And then the other frontal boundary basically from Alberta down through Oregon. And then some sort of other frontal boundary in the Carolinas. And no wonder they're getting wind damage reports in that area. So they're getting frontal boundary helping to trigger activity in that area. And also when you have a frontal boundary, like I mentioned last night, that usually means upper air support. So that's going to help augment your storms. There's the satellite imagery for the Central Plains. Waiting for that to load. I got 40 images loaded up here, but when it's done loading, the flashing will stop. But you can see how storms developed along the Interstate 40 corridor in Oklahoma. So there they are going up earlier today, and they're basically moving south. And then other storms going up in Texas along boundaries down there. And there's our monsoon. Some very good storms right here north of Phoenix coming out of the mountains. And those appear to have... There's that better. Okay, so there's the storms. Very good ventilation. Look at how long those anvils are. And they are propagating to the southwest. Kind of doubtful that they're going to reach Phoenix tonight, but probably a very grand sight looking out to the north there this evening. Okay, quick look at a sounding. We'll look at Fort Worth since we're in the area. Looks like moisture problems at Fort Worth, maybe a little bit of moisture close to the surface. But if you try to mix this, you're going to get like maybe a moisture line like that. Temperature line, 93 degrees, it's going to be something like this. So not a whole lot of instability and a little bit of capping in here. Lake Charles, I'm sure they've got even better moisture. Yeah, you see here low 70s with upper 60s aloft, up to about 4,000 or 5,000 feet. Much better moisture there. And just for something different, we'll pull up Nashville. That's going to be somewhere along that boundary. And some pretty decent moisture there. This is going to be dew points around 70 up to about 3,000 or 4,000 feet. So if we lift this with 88 degree temperatures, looks like some pretty good instability. So I think as we go further east, we're getting into more unstable air. Very cool temperatures up there at 500 millibars. So let me go out to, let's see, maybe Greensboro. And we see very steep lapse right there and very cool temperatures aloft. Not much moisture, but I'm sure we could, some of that moisture will make it up into the Carolinas. Probably made it up there as the day went on, and you combine that with these steep lapse rates and you're going to get some pretty good storms going with that. Okay, let's see here. We'll just take a quick look at conditions aloft. Haven't really looked at this in a while, but you can see the main jet stream well up to the north. It's going to fall basically where the black lines are kind of packed together. So kind of like that. And also, it's going to lie between the pale yellow, like you see right here, and the darker colors. So you're going to place it kind of like this. So the actual location of the jet probably something like this, kind of broken up into segments. Maybe something like that right there, and grazing the Carolinas right there. And as we can see, pretty quiet here in Texas, and not much sign of a strong upper level high. Okay, we'll take a quick look at the forecast from the high-resolution rapid refresh. You can see the line of storms up there in Oklahoma, and I think it may be initialized a little bit too far north. I think the cells are more like near Ardmore and Atoka, somewhere in this area here. So model a little bit off, but the general trend is to basically move that south, continuing to impact North Texas through about 9 o'clock, 10, 11, and then that should start dying off. However, that will leave boundaries out in this area, so we'll have to kind of watch where those end up. Now, one way you can find those boundaries is looking at theta E. So let me run these charts here. There's the current chart for Texas, and you can kind of see that boundary right there in Austin and San Antonio. That's kind of where I showed you on that deformation chart. Not as hard to, or not as easy to see in Northeast Texas, but the model putting maybe a few boundaries right there. So we can kind of track these overnight by just kind of inspecting the data overnight. So we can see by 1 in the morning, maybe a couple boundaries in Tyler, Palestine down to Austin. And we're going to expect the boundaries to kind of be there by the time convection starts up later in the day. Now we do get some drying tomorrow. This is kind of interesting. This is during the afternoon. So we're getting some very dry air impacting this area. So we'll take a look at that. And there's new convection going up in northeast Texas along one of those old boundaries. So where did this dry air come from? This is the 850 millibar chart. So this is showing dew points or moisture up at 5,000 feet. And it looks like we've got this depressed area of low moisture. And I noticed this yesterday coming out of the Gulf of Mexico. I don't know where that came from, but there is dry air out in the western Gulf, and that is advecting inland. And you can see it moving up into Texas. So maybe a little bit of drying, because that's going to mix down to the surface and bring low dew points down to the ground. And we can see that's going to impact probably the southern half of Texas and maybe Louisiana, New Orleans, like that. Here's the front coming southward, and we'll just take a quick look what's going to happen over the next couple of days. Oh yeah, look at that dry air making it all the way up to Shreveport into Louisiana. And we can see more dry air in the Great Lakes right here. Okay, so by Wednesday and Thursday, we're just under this very dominant southerly flow. A new front coming from the north. There's the leading edge of that front. And most of the low-level flow, or this 850 millibar flow, heading up to the north, the Midwest, right up in Illinois, Missouri, impacting the fronts right around this area. So that's going to be the best area for precipitation. So Illinois, Missouri, Iowa, probably a good chance of precip around midweek. Then we'll tie that to the upper level flow. This is 200 millibars. You can see the upper level high over Arizona, and then just over the next week or so. Jet max rounding the top of the ridge into the northern plains. There it goes into the Great Lakes, and the high does build into the central plains by midweek. So it looks like things will be heating up a bit. Kansas, Oklahoma, North Texas. And that'll stay in place until the weekend. And then maybe start receding later next weekend. And the flow gets really amplified about a week from now. So that's going to probably give us some major changes in the weather over the next week or so. When the pattern's really amplified, we tend to get some unusual weather events. Nothing significant, but it's definitely going to give us some material for the webcast, so that's kind of good. Look at that. Yeah, see that? The jet stream, that's very unusual. 55 knot flow aloft. Any storms going up in Texas are going to be very well ventilated, and they're probably going to be moving south or southwest. So we're going to look forward to what happens over the next week and a half. Then the pattern goes zonal again, and we just get a little bit of a trough over the eastern U.S. down into the South Texas area. And up north, pretty flat flow right there. Right, let's go into the GFS forecast. This is probably not the ideal. This is more of a wintertime chart I would normally use like in November, December, January, because you can see it's kind of hard to find the outflow boundaries. I can kind of find it by the edge of the convection like this, but I'm not really too sure how reliable that is, especially as we get later in the sequence. But this will give me a good idea of just, the synoptic scale flow, and I can see that the Gulf is just kind of opening up here. Got a new front coming down from the northern plains. And then by Thursday and Friday, front slowly sagging southward. We've got a bit of a baroclinic low in eastern Kentucky, eastern Tennessee, in the Appalachians. There's a leading edge of it right there. So yeah, some of the synoptic scale details very easy to pick out. So we're looking at Saturday here, and this is where the pattern starts to get a little bit unusual. We start building that very strong upper level jet. So that should help propagate that front southward. The main system moves out into the eastern U.S., and there it is on Monday. And at this point, it looks like we've got boundaries all the way down on the Gulf Coast. A little bit of a high in the Midwest right here, bringing some dry air southward. GFS going for a little bit of a hurricane off Baja California. We always have to watch these for possible recurvature. So obviously that'll bring huge effects into the southwest U.S. and even into Texas and Kansas if they do take a track like that. And yeah, this one is kind of drifting north. It's weakening, but the moisture field is still there. Then let's see, August 2nd and August 3rd, big high over the Midwest. So this is a big frontal high pressure area. Main front well to the south, so this is just kind of reinforcing that. New low in the northern plains. So maybe something like that for the fronts. And that moves mostly through Canada into James Bay around the 5th and 6th of August. And pretty soon, August 21st is going to be in our sights, and that's when the eclipse is. And I've got some ideas for covering the Eclipse Forecast, so I'm going to try to put something together. It's probably going to be pre-recorded, but maybe over the next couple days I'll have something on the channel that'll be a very unusual look at where to go for spotting the eclipse. I don't know how many of you are going to be out for that, but I'm already trying to figure out how to get up there. Probably to Nebraska is what I'm thinking about heading towards. Sue M, Illinois, saying stormy night in morning. Let me give you all some satellite imagery to look at. Move this a little bit east. Okay. There we go. Look at the Midwest and some of Oklahoma there. So yeah, Sue M saying a stormy night there. Mike Estwick caught a wicked outflow boundary on radar in Illinois earlier. Ryan says strong storms blasting on through North Florida, Georgia, and into the Carolinas today. Carl Berghoff uploaded a new picture. Ron Chalfant saying hello. Ryan says family in Nashville had severe storm pop up overhead. Maybe I can show that to you real quick. Let's take a quick look at the North Carolina area. This is Texas. Just showing popcorn thunderstorm activity kind of propagating to the south. I'm going to bring up one of the Carolinas radars. I'm going to try Greensboro. And the data is coming in. Jeff Day says, I hope you mean Oklahoma when you say don't worry about drought. We're really starting to need it southwest of Tulsa. Yeah, we've got that upper level high building over next week. That's going to be a problem, but I think there will be some relief at some point over the next couple weeks. And I know these storms we had today just kind of dodged. It looked like they kind of skipped right over Tulsa. 68 degrees in Maryville, Indiana. 81 in Indianapolis, not good. Minor flight delays, according to Ryan, in Charlotte, North Carolina. Bit of buffering, according to Michael. Burl H noticed a bit more buffering. Okay. Michael says he's already gotten off work for the eclipse since it's so close to where he is. And Mike Estwick, he needs to see much of it. He'll see it in Denver. Okay. Yeah, there's the storms there in the Carolinas. It looks like they've pushed to the south. I think Athens, Georgia is right around this area. I'm not too familiar with all the cities out in this area. Maybe I'll just put on the city names here real quick. Augusta, okay. I'm trying to remember where Athens is. I thought it was somewhere in this area. Maybe I'm wrong. Okay. Anyway, I can figure that out another time. But there's a pretty good storm right there in eastern Georgia. We'll take a quick look at the velocities, and well, this is showing. Oh, I'm sorry. Yeah, this is outflow. So I think we got kind of an outflow storm right there. We are sampling it up at 8,000 though, but this to me kind of indicates maybe some divergence at the surface, and yeah, definitely does have that bow echo appearance. So that'll probably be propagating to the south or southwest there. And what we see over central South Carolina, mostly a big trailing stratiform anvil. Main cells, they look to be well to the south. I'll pull up this radar here at Savannah and just see what that shows real quick. And while that loads, I'm going to take a look at the SPC products. No watches in effect. There's all those storm reports in North Carolina. No mesoscale discussions. So it looks like not any widespread severe weather or anything like that going on. So there's another look at the activity. Looks like a lot of it has actually died off. You can definitely see the outflow boundaries through here. But the actual convective towers, there's only a few left in this area, and most of the big ones are well to the west in Georgia. Let me see what the storm tops are on that. You can see the anvil. Yeah, look at this as I go from lower to higher tilts. 2.4, 3.1, 3.9, 5.0, 6.4, 7.9. So yeah, let me do a cross-section and you can probably see that. Yep, there's the anvil. Just kind of overhanging a lot of southern South Carolina right there. In the base of that anvil, about 25,000 feet, there's probably a little mammatus in there. So if I lived in that area, I would probably go outside and maybe look at if maybe there's some good photos in this area here between Columbia and Savannah. Okay, let's see. I'm probably just about done here, so let me get my closing music all queued up, and I think I'm pretty much done for tonight. Let's see here, checking on chat, nothing much new, so I guess, guys, I'll see you tomorrow. Have a good evening.